Every place on Earth carries a record: roads, fields, roofs, water, light, and change through time. Planetary causal inference asks how to connect that record to the strongest question in the applied sciences: what caused what? The point is not to replace field studies with pretty maps. It is to connect localized experiments, natural experiments, and observational designs to Earth observation and AI systems, so causal evidence can travel across space, across time, and across scales. The reason this agenda is possible now is convergence. The data axis has expanded. Landsat archives, Sentinel imagery, near-daily commercial imagery, night lights, climate products, and other planetary scale records. The modeling axis has expanded too. Vision transformers, Earth observation foundation models, and multimodal systems can compress rich images into useful representations. But the causal axis still has to lead. A high-accuracy prediction map is not a causal estimate. PCI is design first. Define the estimand, defend identification, and then ask what planetary data can measure. A practical PCI workflow starts with a causal question. Are we estimating an ATE, a CATE, a spillover, a mechanism, or a transportability target? Next, lock the design, randomization, difference in differences, matching, RD, IV, or another identification strategy. Only then do we align imagery to units and time windows, keeping pre-treatment covariates separate from post-treatment outcomes. Images become features or embeddings. Estimators produce effects and uncertainty, and validation checks whether the result survives spatial and temporal stress tests. One core use case is treatment effect heterogeneity. The average effect can hide where an intervention works best, where it fails, and why. Satellite imagery adds context that surveys often miss: settlement form, road access, vegetation, urban expansion, and neighborhood structure. The nitty-gritty matters. A single crop size may miss the signal. A small patch can capture household-level detail, while a larger patch captures markets, terrain, and regional context. Multi-scale representations concatenate those views, then feed a familiar CATE estimator such as a causal forest or R-learner. PCI also changes what we can measure in observational and quasi-experimental work. Pre-treatment imagery can proxy parts of local context that otherwise remain unobserved: infrastructure, land productivity, remoteness, or the settlement patterns that shape treatment placement. Post-treatment imagery can become an outcome or a mechanism, rather than a covariate, and because the same Earth observation stream covers the original study region and new target regions, it can support transportability. Not just did it work here, but where else might it work, conditional on comparable context? For randomized trials, PCI creates a new diagnostic, the remote audit. Before outcomes are analyzed, ask whether pre-treatment imagery can predict treatment assignment, missingness, or selection into the sample. If the answer is no, the imagery is consistent with the design. If the answer is yes, the audit does not automatically invalidate the study, but it points to a concrete place to look: re-randomization, balance checks, documentation, or design adjustment. This is satellite imagery serving the credibility of the causal design. The agenda is powerful because the data are rich, but that richness creates failure modes. The biggest one is leakage, using imagery captured after treatment as if it were pre-treatment context. Spatial dependence is another. Nearby units are not independent just because rows in a data set are separate. High-dimensional models can overfit small experiments, and transportability can fail when target places differ in ways the imagery does not capture. The safeguards are concrete: time windows, blocked validation, overlap checks, uncertainty propagation, and ethical handling of sensitive locations. The research agenda is now coming into focus. We need better multi-scale representations for local and regional dynamics. We need debiasing methods for machine learning maps used downstream in causal analysis. We need multimodal representations that combine imagery, text, administrative data, and AI agent retrieval without losing identification discipline. We need remote audits, open RCT repositories, reproducible software, and simulation systems that let us test methods before deploying them. The North Star is simple: design first, imagery second, validation always.